I need to explain about the standard score, which is the Z score. If you remember, I mentioned it, but like orally last session, actually the Z score can be calculated for any value. Okay, I have a distribution and I pick any value and I ask what is the Z value for this value. Okay, and the standard score means how far is it from the mean, but not in centimeters, not in meters, not in kilograms, not in anything, but in standard deviations. Okay, how many standard deviations is this value far from the mean? Okay, so how can we calculate this? We need the distance from the mean. So you can see here, this is the value I'm measuring the Z value for. Okay, so I have here, for example, blood glucose or whatever it is, like minus the mean, okay, divided by the standard deviation, and this gives me the standard score. Okay, but here it is clear, but how can I benefit from this score? Okay, as you remember, when I have a Z score of lower than 1, then I know that this value is really close to the mean. So it is like lower than 1 standard deviation from the mean. Okay, so it's included in the 67%. Those like the central category. If it is lower than 2, I understand that they are like in the 95% of the whole population, those normal 95%. If it is like lower than 99, sorry, if it is lower than 3, okay, 3 standard deviations, that means that it is like included in the 99% of the population. And when it comes further from the mean, the Z score becomes higher or lower, okay? Because the Z score can be like positive to the right or negative to the left, okay? So if it is negative, so I know where the situation of this point is, and I know, for example, it is like 5 standard deviation far from the mean. So I know that it is like really far away from the mean, okay? So, do you have any question about the last session, about the things we did before, but hopefully not about SPSS, because I don't have SPSS on this computer. So you can ask the SPSS questions in the next call when we move on to the second computer and when we move on to do the statistics on SPSS. Anything? Any? Okay, then we move on.
Are we going to have something like
what?
Are we going to have something like some kind of test if we are doing good it or not?
I'm sorry, Sarah, but I'm not hearing you. I think the audio is interrupted. Yeah, maybe if you can just repeat the question for the last time, or maybe type it in the chat room.
Are we going to have something to test our knowledge later, like in the end of the course or something?
Actually, you tested by applying the concepts you understood by doing some statistical tests, okay? So if you understand what we are doing right now, then you are testing your knowledge about the previous topics, okay? And if you succeed to apply that on your own computers, then you understand what you are doing right now. Okay, is that satisfying?
Okay.
Okay, so now what are we going to do is to calculate the sample size for some questions. Okay, and the calculator is called Piface. I will show you the website where you can download this Piface sample size. Here it is. Okay. Yeah, the website is not so like charming, but you can download the software from here. You should download the Piface.jar, and you should also download the Java in order to be able to work on the Piface. Okay, so this is the program that can calculate the sample size for us. Yeah. Okay, it's an old one and a very basic one, but it can calculate most of the sample size we need. Okay, this is the first interface, and those are our options. Okay, we will discuss the options before we go on. Okay, what are the most important things we thought about when we wanted to calculate the sample size? Okay, do you remember them? Like, is the population infinite or finite? Do I have any indication about the effect size? Do we have any assumption about the difference between the two proportions? Okay, do I have the proportion of the mean of the normal population? Okay, and so on. Okay, and as I told you, it differs from a test to another. Okay, so if my primary outcome is a continuous outcome and my primary test is a t-test, then I need to calculate for a two-sample t-test. Okay, if I have two groups and I want to compare the continuous data from one group to the continuous data from the other group, I will need this. If I have one group and I have continuous data for this group, and I'm going to compare those to the normal distribution of the population, the normal population, and I know that before, but I don't have any controls in my study, then I'll take one sample t-test. Okay, if I have a proportion, I just like ask who is happy in the streets right now, and I want to compare it to my city. Okay, I asked just 50 people. Okay, and I found that the proportion is high. Many people are happy actually out of my sample, but I want to compare that to the normal distribution, not the normal distribution, but the normal proportion in my city. Okay, so what should I take? A test comparing two proportions. Okay, I have two proportions, a normal proportion for the whole city and a proportion for the sample I took. If I have two groups with two proportions, of course, that also applies. Not t-test, chi-square test. Yeah, for the t-test, for the continuous data, we have those two. For the chi-square, for dichotomous or categorical data, we will have this test comparing two proportions. Okay, if I just have one proportion, okay, but I need to understand what is the confidence interval of this proportion. I will take this confidence interval for one proportion. Okay, I just tested. I don't know anything about the population in my city, but I just took a sample and I found that this sample has like 50% people who are happy. Okay, so how could I understand, or how can I appreciate or estimate the confidence interval? Okay, it is by this calculator. What is the sample I need to get a standard deviation or a confidence interval of a specific characteristics. Okay, so we are going to start with those. As you can see, we have for categorical data, for continuous data, different questions. Of course, we will have other calculators, for example, for linear regression, and this is actually harder than the other calculators. We will not cover this, but those who understand the very basic ones will be able to do the difficult ones. Okay? So, for the confidence interval for one proportion, I took a sample and I have a proportion and I need the confidence interval for this proportion. Okay? Okay, round down. This is our calculator. I don't know if you can see, actually I can barely see it, but the font can be, I can like extend the window, but the volume will stay the same. The font will stay the same. Okay, so here, what can we see? We have a finite population or an infinite population, okay? And if it is like a finite population, I will choose what is the number, okay? If it is infinite, then I just untick this and I don't have anything here, okay? So I don't know anything about the about the number of MS cases in the world. So yeah, and I want a confidence interval that is like representative of the whole world, and I don't know anything about this. So I think it is an infinite population. Okay, so I will choose that. Okay, what is the worst case? Okay, the worst case, like if I remember that when we calculate the sample size, we don't have our cases yet. Okay, I'm just planning for it, and I'm saying that okay, if I want to do that study, how many cases should I get? Okay, and the worst case, what is the worst case for a proportion? If I tell you like I have a proportion of 90% and another proportion of 50%, okay? Which one do you think is the worst? It's in here.
The 50.
The 50, but why?
Because it's a small sample.
Because it doesn't mean anything important, okay? Because it's similar to the chance, right? But when I have a very extreme proportion, then I know this is not the worst case. I have a very good proportion, which is like if I get like 100%, this can't be by chance. Okay, so I take worst case, okay, and this worst case will make the number higher. Okay, with the confidence interval, usually we use the 95%. Okay, of course we can increase, we can decrease, but usually it is used like this. Okay, and what is the margin of error? Have you just attended the video I sent to you in the morning? Yeah, what do you think can contribute to the sample size? Something other than those discussed before. Yeah, please contribute.
Control.
Yeah, can you repeat it, please?
The control.
Control of what?
of
Re-
sample characteristics.
Yeah, remember this calculator is for one proportion. I just went to the streets and I asked people who is happy, who is not, okay? And I have this proportion, okay? I
The
don't have
variance.
the variance, okay? Yeah, the variance. The variance is actually expressed by several numbers, okay? The first number can be the standard deviation. The second number is the variance. The variance is also a number, okay? What can also be a number for this, the margin of error? Actually, the margin of error is 2 by the standard error of the mean, okay? So remember that we say that we have the standard deviation, and this standard deviation is exclusive for every sample, okay? If I give you a sample, you can give me the standard deviation of this sample, okay? But if I ask you, what is the mean, okay? You can give me the mean, and with the mean, you should give me the standard error of the mean. What is the standard error of the mean? It is like if I have this sample and then I take another sample and the third sample and so on, I will have different means, right? Okay, so for the different means, I have, like, if you consider the mean, every mean as an observation, we will have a standard deviation for the means, okay? So this is standard deviation for the means is the standard error for the first mean, okay? Okay, you don't need to understand that to a very high level, but let's think about it. It's like the variance, okay? The standard error is something similar to the standard deviation. It comes like upper and lower to the proportion. If I tell you I have a proportion of 60%, okay? 60%, how do I type this? 0.6, okay? And I have a margin of error of 0.1, okay? Then you understand that I have 60%, okay? And it is minus or plus 10%, okay? Is that clear?
Yes.
So yeah, so it is similar to the standard deviation, okay, but not the standard deviation. It's actually 2 multiplied by the standard error of the mean. So if you remember, we usually take the mean plus minus 2 standard deviation. So another way to express that is the mean plus minus 2 multiplied by the standard error of the mean, okay? And what is this 2? Actually, it's not a 2. It is 1.96, okay? And what is that? What is the meaning for that? Okay, its meaning is the critical value. What is the critical value? It means that how far should I go away from the mean to like include 95%, okay? So, but I have the confidence interval in here. I have the confidence of 95. So what is the point of the margin of error? Okay, I will tell you. If you go and you take a sample and you tell me I have a sample of 100 participants, the proportion is 50%, and the 95 confidence interval is from 20 to 80. Okay, so you have a confidence interval of 95%. Okay, but it is from 20 to 80. Okay, Another person came to me and told me, okay, I went to the streets, I got a sample of 1,000 participants, okay, and I got the proportion is also 50%, okay, but the 95 confidence interval of me is from 55 to 45, okay, so they both have a confidence interval of 95%, but the confidence interval of the first one is so small, and the confidence interval of the second one is so large. Okay, so this is the difference. It's not efficient to tell you that, okay, I have a confidence interval of 95%. Okay, but how wide is that? Okay, does it make sense now? What? Are you here, guys?
I think it's better if you repeat it, please.
Okay, I will. Somebody went and told me I have a proportion and I have a standard, I have a confidence interval of 95%. Another person came to me, he told me, okay, I have a proportion and a confidence interval of 95%. Okay, actually, I asked them about the proportion. Both of them told me that they have the proportion of 70%. Okay, so there is no difference in the proportions they have. Okay, but when I asked them about their confidence interval, they both have a confidence interval of 99 and 95%. Okay, they both have that range that includes 95 attempts. If they repeat their experiment for 100 times, they will have that range of 95% of these attempts to be in the range from this to this. Okay, they both have a range. Okay, but one of the ranges is so small and the other one is so large. Okay, so here what I said is the definite and infinite doesn't mean anything for this statement. The worst case, okay, it means it is different. When it is the worst case, the 50%, it will be harder to prove, okay, that I have a small confidence interval. Okay, when I am on the margins, okay, it will be easier to get a smaller confidence interval. Okay, so why do I need the margin of error? Actually, the margin of error says, okay, you have a confidence interval of 95%, but how large is it? Okay, so when I go to a person and I tell him I have a confidence interval of like from 50 to 100 and my proportion is 75. Okay, that's not good. Do you agree? When I go to the same person and I tell him I have the same proportion, 75%, but my confidence interval is just from 70 to 80. Okay, does that make any difference in your mind? So the width of this confidence interval is expressed here by the margin of error. Okay, so before I go to the streets, I should like remember if the proportion, if the population is finite or infinite, what is my estimation? Actually, my friend went last year, and his proportion was 60%. Okay, I need the same confidence interval, and the margin of error actually. Okay, so for those, if I stop here, I will need a number of 111. Okay, but that will give me, if you can see here, it's like nearly 1. Okay, 1 per 10, so it's like 10%. Okay, so if I go and get 111 patients, okay, I will tell you I will have like probably the same proportion, 60% plus minus 10%, which is the margin of error. Okay, but if I go again and I gather, look what I will do. I will take more patients. I will take 1,000 patients. Okay, I will return and I will tell you I have a, sorry, I didn't take this. This is 16. Okay, yeah. When I will return this time, I will tell you I have a proportion of 60%. Okay. Hopefully, if nothing changed from last year, but my margin of error, okay, which means like 60% plus minus 3%. Okay, isn't that better than saying 60% plus minus 10%?
Yes, the less the range, the more precise our work.
Yeah, exactly. This is what I'm saying. So if I want to have a smaller range, I will need a higher sample size. Remember that I don't go and get whatever I receive and then calculate the margin of error. Actually, before I go there, I need to decide, okay? I think I will have a proportion of, for example, let's say 90%, okay? This is the proportion I'm expecting, okay? What is the margin of error what is the margin of error I need, okay? Do I need a margin of error that goes from 90% to 80%? Do I accept this margin of error, or do I need a very precise margin of error, a very small range? Okay, no, I need a range actually like 5% plus minus 5% is okay with me. Okay, so I will go to the margin of error. Remember that, yeah, like last time I changed this, but usually I don't change this because I don't have those numbers. I will go here and I will say I will accept 5. This is a 5%. Okay, so if I have a proportion of 90% and I accept a margin of error plus minus 5%, okay, how many participants do I need? I need 137. I go gather them. If my assumptions are correct, okay, then I will have this margin of error and this proportion. Okay, does that make sense?
Yes.
Okay, perfect. I went back, then I said, okay, I don't want to spend a lot of time like collecting data, so I will accept a margin of error of 10%. Okay, so I will increase this to 10%. What do you expect for the number? The n for this calculation is the number of cases I need. Will it increase or decrease?
Increase.
No, it will decrease.
Exactly, it will decrease. Why? Why it will decrease? Because I'm accepting a higher
More error, so I need less.
Okay, so
okay,
I don't need so many participants. Look at this. I will accept 10%, and this is the 10. Imagine I just need 35 participants. Okay, this is a huge difference, right? I need 100 more participants, like 3 times my my previous number. Okay, just to get like half the range. Okay, so if you agree with this, we will move on to the next calculator. Yeah, can you just put thumbs or anything? Or actually, I don't see. Perfect. So, okay, so for a one proportion, it's an easy situation. What do we have more? Test of one proportion. Okay, what does a test for one proportion means? Okay, it means that I will go and I will have a proportion, and I have a normal proportion, like at home, from the normal participants, from the general population. Okay, and I need to compare this to this. Okay, when I'm comparing two proportions, what is the meaning of this? It's a chi-square. Remember, two proportions, so I have two numbers and two numbers, so I have a 2 by 2 table. Do you remember that? Okay.
Yes.
Perfect. So I'm comparing two proportions, but we have two ways of doing that. Okay, either I go and I gather some of the patients and some of the controls, so I receive two proportions, or I have a proportion like preserved at home, and I gather a new proportion and then go back and compare it to the old one. Okay, so this one, test of one proportion, it means I have one proportion and I'm testing it to the norms. Okay, what is the null value? What do you expect the null value to be? It is the one at home. Okay, the one I'm not gathering. Okay, like, okay, it is like 50%. Okay, what is the actual value? The actual value, I went to the streets and I received it. Okay, and remember, to calculate a sample size, I will need to estimate it or to expect. Okay, do I expect it to be 10% higher? Okay, I expect it to be 10% higher. So the normal one is 50%, and I expect 60%. Okay. So what is the power? Do you remember that term? Okay, I don't have power when I have just one proportion, okay, and one confidence interval for this proportion. But when I start to compare, those are statistical tests. And when I have statistical tests, I have true positive, true negative, false positive, false negative. Okay, and when I have false negative, I have the proportion that completes the false negative, which is the power. Okay, so there is power, and remember that we usually accept a power of 80%. Okay, we say that it changed from a study to a study and from specialty to specialty, but normally in medicine we don't expect a power of lower than 80%. Do you remember the definition of power? It's the probability of getting the difference if there is actually a difference. Okay, so if there is a difference and I don't get it like in 20%, it is okay. But if I don't get it in 50%, this is not a study, okay? This is a game. Okay, so if there is a difference, I need to get it at least in 80% of the cases. Okay, this is acceptable. So I will put the power to be 80%. Look what is happening in here. Look, I'm increasing and this number is increasing. I am increasing and I am still greedy. I need 80%. Okay, now I reached 80. I started, I think, with 30, and now I need 200. Okay, so now if I have a 50%, like the normal population is 60%, and I'm going to rheumatoid arthritis patients. I'm asking them about smoking. Yeah, I'm thinking that smoking can affect the joints and might cause rheumatoid arthritis, okay, for example. So, and I expect that 60% of those with rheumatoid arthritis are smokers, but in the normal population, just 50% of the normal population are smokers. Okay, how many rheumatoid arthritis patients do I need to screen to be sure with a power of 80% that there is a difference between them? Okay, so I put the power and I receive a sample size of 200. Okay, remember that we will need to put this. This is exactly the same as when I choose a confidence interval of 95% or an alpha of 5%. This is the same. Okay, what is the alternative? Okay, if it is not like this, then the alternative will be like the two proportions are the same. Okay, well, we have other options like, no, I know they are higher, but I'm expecting them to be closer. This is a different test and it needs different calculation. But when they are actually, I expect them, the alternative, to be like they are the same. But nowadays, I think more rheumatoid arthritis is happening in those who smoke. So smokers will contribute to 60% of the population of rheumatoid arthritis. Okay, so we will choose this. Okay, this is the usual one. The usual one is there is no difference. They are the same, and I'm expecting a 10% difference. Okay, let's test for that. Okay. You don't need to care about this. Okay, so is this calculation, is this calculator understood by you? Oh, perfect. So we will move on. What is the next one? Is test comparing two proportions. I'm going to gather some controls and some patients, and I will do a comparison of those two proportions. I will also need a power. Okay, right? I will need a power. But what is the difference in here? Okay, remember that it is quite similar. When I'm comparing to a proportion at home, I need to put to remember it, okay, and I need to expect the new proportion. Okay, so if I'm going and gathering two groups, I need to expect the proportion for those two groups. Okay, so I will need that. Okay, you might ask, okay, if I don't have any previous study and I don't have any estimation of this, you will need to expect, to speculate, or which is better, is like doing a pilot study. Okay, Just take 10 and 10 patients and 10 cases healthy controls, okay? And compare them. Like out of 10, you have 5 in here, and out of 10, you have 8 in here. Okay, then you will put like 5 and 8. Okay. Here we have the number of cases in the first arm and the second arm, and remember that in here we have the option. We might make them equal and we might make them not equal. Okay. We have the alpha. As you remember, the alpha we chose alpha in the last calculator, and the power. Okay. Remember, if it is like the difference is 10% and the number is 100 in each group, my power is 24%. Okay. I don't think you can estimate that. Okay, I have 200 participants and the difference is so huge, it's 10%. Okay, and my power is just 24. This is really small. So what should I do? Okay, remember that we have two options. Okay, one option is in my hand, which is gathering more participants. Okay, look at this. I will increase the number and the power will increase. Okay, now I have like 400 in each group, so I will need to gather like 800 participants to get the power of 80%, or, okay, which is not in my hand, the proportion would be there will be more difference. Okay, look at this, and it is like magic when you make the difference instead of 10%, 20%. I will take this to 40 and look at the power. The power is like it jumped to 1, so I will return the power to, okay, I'm sorry, I can't take this, so I will reduce the number till I reach a power of 80. Okay, of course I can keep that, but I don't need a power of 1. This is so high and I don't need to waste a lot of time. Okay, this is the difference. Instead of 400 in each group, I just need 100 in each group if the difference is 20%. Okay, and if the difference is higher, it's like 40%, I will need far lower. Okay, yeah, I need just 60 participants in the two groups, just the 3 in each group, to reach a significant p-value with a power of 80% when I have a difference for the proportions of 40%. Okay, so is that okay with you? Okay, perfect. Then, and remember, when I have two primary outcomes, two primary tests I need to do, and one of them is telling me, okay, you need a sample size of 20 participants in each group, and the other one is telling me you need 40 participants in each group. Which one should I take? Those two tests are
higher number.
Yeah.
The higher number.
The higher number, of course. Why? Because the higher number will make them both significant, but the lower number will make one significant and the other one is like up to the chance if it is significant or not. Okay, what else can I do? I can take a one sample t-test. One sample t-test, it means that I will go and I will gather, I will collect data about the weight of the patients in my hospital. and I will compare it to the weight of the normal population, which is like already published, like normative data. Okay, because I think nowadays, those who are obese are more like susceptible to be admitted in the hospital in that department because of some reason. Yeah. Okay, so I will go to this one sample t-test, run. Okay, so we have new stuff in here. Of course, we will have the power. Of course, we will have the n. Of course, we will have the alpha. Of course, we will have two tail or one tail. Okay, and you remember that when I am actually sure that those in the hospital are like overweight, then I don't need a two tail. And if I remove this tick, the power will jump higher. Okay, why? Because a two-tail test will make the p-value higher. So if I make it a two-tail test, I'm making my my test like harder. I need more sample size. But if I make it like one-tail test, I'll need a fewer sample and I will get a higher power. Okay. So we will not discuss the two-tail or one-tail. We will not discuss the alpha. We will not discuss the n or the power now. What we will discuss is the sigma. What is the sigma in your opinion?
انحراف deviation.
Yeah, it is a standard deviation. Okay, so I have a standard deviation of 1. Okay, but 1 what? Okay, 1 what? Actually, in this calculator, they do not need any information about this. Yeah, no, the sigma is the standard deviation, but they are asking how big is the standard deviation. I can make the sigma half. Okay, so they are asking what is the sigma, but I don't understand what is the unit in here. Okay, they say we do not need the unit. Okay, yeah, remember I just remembered that you can go here to the help t-test info and it will open some information about this calculator. It will tell you about the sigma, about the this variable, about this. So just make use of this. You can help yourself about Piface. The graph, we can use the graph right now. Yeah, we will try to use the graph right now. But after we explain this, just please remind me. Okay. So, well, what did we say about the sigma? We don't have a unit, but why we don't have a unit? Just let us cover the second variable and you will understand why. This is the true mu minus mu0. What does that mean? I have a mean of the population or the sample I collected and the normal mean. Okay, what is the difference between them? Okay, if I say the difference is half, okay, then I'm defining a unit. Okay, so the sigma will be on the same scale. So they do not care because they just need us to put the sigma and the difference on the same scale. If there are 5 and 5, it is okay. If it is 0.5 and 0.5, it is okay. Okay? If it is 500 and 500, it is okay. It means they are comparing them to each other. Okay? They do not need the unit. They're comparing those or whatever is the scale you have. Okay? Is that clear? Perfect. Any questions? Any questions? What I was trying to do is like, I changed them. They were like 0.5 and 0.5. And I had a 25 sample size and a 99, like not 99, 0.9986. Okay. And when I change them to 1 and 1, they stayed the same. And if you change them to 500 and 500, they will stay the same. Okay, so do you understand the concept in here right now? I hope it's fine. Okay, so I think we don't need to explain more about the difference. I need to expect the difference even if I don't have it. Okay, I expect a difference to be higher. Okay, I expect the difference to be really high. So look, the power jumped to 1. Okay, I don't need that power. I just need a power of 80. Yeah. If the true difference is that big, if the true difference is 3 standard deviation, okay? Remember that if it is like 3 and the sigma is 1, if the difference is 3 times the standard deviation, how many patients will I need? 4. Okay, but usually we do not have such a difference. Okay, we usually have like the difference is the smaller one and the standard deviation is the bigger one. Why? Because we have a lot of variance, a lot of factors. Okay, and the difference is really small. Okay, so we will change it. We will put the difference to be 1 and the standard deviation to be 3, and you will see the difference. Okay, I have a 7% power. I will increase my power. I will increase the number. I need a power of 80. Yeah, I will need about 80. Okay, so it's a huge difference between 4 and 80. Okay, can you appreciate the concept in this? Let's move to the last calculator and finish this session. 2 sample t-tests. Okay, what is a 2 sample t-test? I will weight people in the gynecology department, and I will weight people in the ENT department, and I will see the difference. I will test for the difference. Okay, so here it is a little bit more difficult. 2-tailed, 1-tailed, alpha or an alpha. We are testing for the equivalence. We are not testing for the equivalence. Okay, so we just leave it as this. Okay, equal sigmas. Do you expect the variance in one to be higher than the variance in the second one? Do people are like have a very small confidence interval for their mean in the first group and a very big confidence interval, and they are so heterogeneous in the second group? Okay, if it is not, you need to change this. Okay, I need a power of 80, and the number is 77 and 77. Okay. Yeah, I'm sorry, I just forgot this one, the true difference of the means. Okay, so it is quite similar to this one. If you agree, it's quite similar. We have a sigma in here, but two sigmas in here. We have a difference in here and the difference in here. We have the number, two numbers, power, one power, alpha, two tails. Okay, so do you have any questions before we end the session? Okay, then I hope you calculate your sample size before you conduct your own studies, because if you don't do that, okay, you won't have like a statistically significant outcomes. Okay, and this is a problem for many studies. Usually they they make a joke. I calculate and I gather, collect data, everything, and then my p-value is not significant. Okay, the problem is not at the end. The problem is at the very beginning. Okay, so see you in 10 minutes or 15 minutes. Okay, and yeah, have a nice break. Statistics, Crosstabs. Okay, so we have rows and columns. Okay, usually we use the rows for the things that are independent. Okay, and the columns for the things that are actually dependent. Okay, the things that depend on the variable in the rows. Okay, so maybe graduation affects or not. University or faculty affects graduation. Okay, we have more graduate people from the faculty of dentistry and the faculty of pharmacy. Okay, so I will do that, and I will do press OK. What do I have? What do I have in here? Okay, it's not a 2 by 2 table because for faculty I have 3 options, but it's a 2 by 3 tables. By 3 tables. Okay, we have here the totals. We have here the totals for the rows. Here the totals for the columns. We have those 6 numbers. This 0 because we don't have any not any dentistry student. We have just one, and he is graduated person. For pharmacy, we have 1 undergraduate and 2 graduated, and so on. Okay, what do we have in here? We have 4 missing data for the for this comparison. Okay, and we have 45 who are valid for this comparison. Okay, so this is a good table, but what are our options for that table? I will hit the same crosstab, but I will check display clustered bar chart. Okay, clustered bar, and we will see why it clustered bar. Okay, usually we have a bar chart, but here we have a cluster. Why? Okay, what else can we have? Let's take the cells. Okay, we have the observed, we have the expected. I will check them both. Okay, I will take that and continue. Let's not make it so complex from the first time. Where is it? Okay. Here we have. Yeah, just took a lot of time. Okay, here what do we have? The same first table. For the second table, we have here the same numbers in here, but we have expected count. What is the meaning of expected count? Okay, we will discuss that later, but let's now look at the faculty. Why is it clustered? We have a cluster for dentistry, graduated and not graduated, a cluster for medicine, both, a cluster of pharmacy. If you remember, back then, we just had two columns, one for graduate and one for undergraduates. Okay, but here we have a cluster because we have three variables, and in each variable we have two proportions. Okay, so what do I use the expected count for? Okay, just remember about the statistical tests and what do we need to understand about those numbers. To what is the logic of a statistical test in a 2x2 table? Do you remember? Actually, we compare the numbers we get to the numbers we expected to be. Okay, and how do we measure those expected cells? Okay, if I say that the faculty doesn't affect graduation, they will take the 0, 17, and 1, and the 1, 24, and 2, and they will put this count, okay, and out of this proportion, they will divide it on the three faculties, okay. They are saying there is no difference. The proportion in here, the expected in here, should be the same in here and the same in here. But why are they different? Because I have different people in each group, okay. But look at here, like I have one participant and they expect like half of that person, 0.4 of that person to be not graduated. Here we have 3, then they expect 1.2. So they expect 40% too. Okay, here we have 41. So they expect 16.42. Okay, those are all 40%, 40%, 40%. But actually here we are above the 40%. Here we are below, and here we are below the 40%. Okay, so we don't know if this difference is big enough to make a statistical significance or if it is not big enough. Okay, do you agree till here?
So what's the main purpose of expected count?
Well, we need something to compare our values to understand if those values are truly different from the normal proportions.
Okay.
The expected ones are built on the assumption of the null hypothesis. There is no effect on graduation by the faculty. Okay?
Okay.
So, what else can we do with this table? Descriptive, crosstabs. Let's take the same ones, but here, not so. For the cells, let's take the percentages. We can take the percentages just from the row and continue. Here we have like a more complex, but it's a little bit more complex. Okay, what do we have in here? A percentage within the row. Okay, so if we add this to this, we will receive this. Okay, 41.5. This is the actual percentage of this 17, and 85% as 58% is the actual percentage of this. Okay, and so on. Okay, so we will need those. Why? Because if I'm comparing this two with this one, that's not applicable actually, because I have 3 participants in here and 1 participant in here. Okay, although the 2 is higher than the 1, but the percentage in here is lower than the percentage in here. Okay, do you agree? We need the percentages to look at the numbers more precisely. Okay, of course you can add more percentages. For example, in here you can take all the percentages, but the other percentages are not actually of that much use. Okay, for the first one, it is the percentage within faculty. So within faculty, it means within the row. So this percentage is within the row. Okay, what is the next one? Within graduation. So the second one, 0, and the second one, 94, and the second one, 5.6, will make the second one 100. Okay, so the second one will be the percentage out of the column. Okay, and the third one is the percentage out of the whole table. Okay, we don't use them so much, but we use the first one so frequently. Okay, so do you understand those numbers? Okay. What else can we do? I will analyze. Take the same crosstabs. We will take statistics, and here what can we see? The chi-square. Okay, and what is the result of a chi-square? We have no change in the table, but below the table we will have a small table for chi-square, and this chi-square table is telling me that we have an asymptotic significance of 0.684. Okay, so is the difference in that table significant or not? Please. Any answer? A p-value of 0.6.
Significant. No,
Not significant.
not significant.
Exactly. Not significant. The significant cutoff is 0.5. Okay, so the likelihood ratio, we will discuss the meaning of a chi-square test next session. But for now, we need to understand, okay, for the crosstab, we will have such a value. Okay, we will have a number for a chi-square. Okay, and what is the meaning of that? We will discuss that next session. What else can we do? Okay. So, descriptive, crosstabs. Here we have layers for stratifications. Okay, so if I don't just need to measure 2 variables, I need to measure those two variables, but I need to understand the effect of one other variable on one of them. When do I use that? Actually, I use that when I have something that I think is a confounder, okay? That might affect the first and the second thing, okay? So what should I do is to control for that confounder. Okay, then I will divide those in the faculty by that thing. Okay, I think the university is a confounder. Okay, university is affecting the faculty and the graduation. Okay, I hope we can see it clearly. And now we will just remove the percentages, the unneeded ones, and hit OK. You can see how huge the table became. Okay, for here, what can you see? Actually, they divided the faculty for different faculties, okay, according to Aleppo. So, for Aleppo University, do we have a difference, an effect for faculty on graduation? Okay, then for Cairo University, do we have any effect of the faculty on graduation? Then, and so on. Okay, and do you agree this is a good thing to do when I have a confounder or something that I think can be a confounder?
I guess yes, it's giving me a closer look on the percentages.
Okay, a closer look, and it will divide them. Okay, now I don't have any doubt that for Shin University, okay, all of them are graduates. Actually, for the Syrian private university, all of them are graduates. Okay, but actually, I think the differences are in Damascus University. I have the three faculties, and the percentages from the first one is 0 and 100. For the second one is 43 and 56. The third one is also different. Okay, so here I can see a difference, but for others I don't see a difference. Okay, so I decided that I wanna exclude all other faculties and just do my test on Damascus University. Okay, if I want to do a chi-square test on that table, I think we didn't check. Yeah, you can see the chi-square in here. It's a disaster. Why? Because for other universities, we do not have that comparison. We have just the comparison for Damascus University. I don't want to look at such a thing, such figures where nothing is meaningful. So I will go back and I will tell the table, I want you to just select the participants just in the Faculty of Medicine. Sorry, just in Damascus University, and exclude everybody else. Okay, so I will go, but what is the problem? The problem is for the university, I don't actually have a code. If I press on this, nothing will change. Nothing changed in the university. And this is my mistake. As you remember, we used to put numbers, and after that code the numbers to names. So what I will do right now is sort ascending with zeros for all the cases that are not in Damascus University, and put ones for Damascus University. Do you agree now that we need to take that variable and split the file according to it? Okay, now I will take that variable 1. I want a specific condition to apply before we select the cases. So if condition is satisfied, what is the condition? I need variable 1 to equal 1. Continue. So if it equals 1, I will select the cases and everything else will be out of my selection. Okay, of course we can like select based on time. We can select a random sample of my participants. Okay, but now I'm selecting out of my participants. Okay, usually we use this because I need something specific to be done. Okay, what can you see in here? They just crossed all the cases that are not in Damascus University. Okay, and this is a good thing. Okay, now for every analysis I will do, they will cross everything else. Okay, so I will do the same analysis, but I will receive the same one, and this I want to change anything, but look at the result. Now I just have Damascus University and the total, and I have the chi-square for Damascus University and for the total. And actually the total is equal to Damascus University. Why? Because we don't have any other university. Okay, I have this figure that represents just the faculty of the University of Damascus. Okay, do you agree this is a useful tool? But remember to go back to the selected cases and select all cases, because if you keep working on the same selection, you will keep receiving just the results for Damascus University. Okay?
Isn't it better if I copy them to another database and continue working on the sample if I want to work on this one, and keep my, like, the basic database the same?
You can
If
do
there
that.
was an option.
Nobody can say no. But why do you want to do that if it is like just a click? Okay.
Okay.
So, okay, what is the split file? Okay, if I want the results to be.
And how can I, excuse me,
Yeah, please speak.
How can I read the chi-square table? Like, there's a comparison between Damascus University and the total. So, how can I read the chi-square?
Next session.
And why are... okay.
Okay. Yeah, and it's not a comparison
Okay.
between the total and Damascus University. It's a comparison for Damascus University and another one for the total. Okay.
Okay.
Okay. So, what does the split file works on? Okay. If I go to the same variable, the first option is analyze all cases. Do not create groups. Okay. So this was the default option. But here we need to compare groups. Okay, I will, and the groups will be based on this. What do you remember about those? Those are Damascus University, the group of 1, and not Damascus University, the group of 0. Okay, and I'll press OK. Now you can't see anything in here, but let us pick something and do an analysis for. For example, I will need a descriptive about the ID and another descriptive for, or let's just take the random number. Okay, do you remember what does the descriptive analysis mean? Like it means it will give me the mean, standard deviation, everything. Okay, I press OK. And what did they do? They split the results into two groups, a group of 38 for Damascus University and a group of 8 for everybody else. They reported the same, the mean, the maximum, the minimum, the standard deviation, but they split the file into two results. Okay, I'll go back. I will remove my split. I will do it again, and you will see the difference. Okay, do you see the difference between those? In the last step, we selected some data. So we are doing the analysis just to those. And if I do that in here, okay, we will just select those and they will just report that line for Damascus University. But there is another option, like splitting the file and telling the, everything for the first category and everything for the second category. Okay, and this was not an option when I press the analysis without the split. Okay, so